Welcome to this video of aspireforgmat.com. Before attempting this question, please take the practice test at www.aspireforgmat.com and then verify your answers against this video, which will be available after you answer the question at our site. The link for the free Aspire for GMAT course is also available in the description box below. Just register on the site and enroll for the course. There are many such tests available. If you have any doubts or queries that you would like us to clarify, post in the GMAT forum and we will answer your questions. Our instructors can also solve these problems in a video which will be available at our site for your benefit.
Okay, this is going to be our next problem. Is y an integer? So this is a simple question. It's asking for whether y an integer. Very short question. If you see, there's just two small options given. One is that y cube is an integer and one is 3y is an integer. It's a very small question, but at the same time something that actually can fool us. So let's see how we would go about this question. Let's have a look at this question. It states that y is an integer or not. That's our question. We need to find out whether y is an integer or not, and it's a very simple question. It's a question based on number properties. You need to work on numbers and confirm whether you can find an integer value for y always, when it sticks to the criteria that's mentioned in these two statements. Now, the first statement says that y cube is an integer. Does y have to be necessarily an integer for it to satisfy this condition? Now, y cube could be an integer even if y is not an integer. Suppose y is, for example, y is 2. Y cube would be definitely an integer. An integer cube taken to any power is going to be an integer unless it's an inverse, in which case it might not, it might be a fraction. But in this case we know the power is positive power, so y, if it's just any plain old integer, it's going to always turn out to be an integer, so that is not a problem. But what if y is equal to a cube root value of something? Say y is equal to cube root of 2. Now y cube will definitely turn out to be an integer, but y need not be an integer in such cases. So this gives us, this particular condition gives us both yes and no answers, and therefore this is clearly insufficient. Now since this is insufficient, we know that A cannot be the answer because A says that 1 has to be sufficient, and D cannot be the answer because D says that 1 and 2 both are sufficient individually. Now those two answers are out of question. Now second option is 3y is an integer. Now this is where normally we all would stumble, because once we see the tougher option, we know we've sorted that out probably in the right manner. We quite often come to mistake with the simpler option. Now 3y is an integer means y could be an integer, because any integer multiplied by any other integer is going to give us an integer. Now what if y was a fraction? What if y was something like 7 by 3 or some x by 3, and I multiplied it by 3? It would definitely give me an integer, but then y would not be an integer. So irrespective of whether y is a fraction with a denominator 3 or an integer, I might get an integer as a value for 3y. So this is definitely not sufficient, because it gives us possible answers where y could be a fraction or an integer. So since this is insufficient, B is also out of question, because B says 2 needs to be sufficient. Now let's consider it together. Now when you consider it together, it turns out pretty funny, because we need to consider all different sorts of, when it comes to number values, we need to consider different sorts of numbers, different sorts of fractions, decimals, positive values, negative values, even 0. So until we find that there are contradictory values, contradictory answers that is obtained from the same option. So we need to work on it, and the more we work on such number problems, we would know which one to test first, whether we need to test fraction first or positive values or negative values. Sort of comes, the more you practice, the more easier it will become. Now when you see this together, that is 1 and 2 option together, you know that y cube needs to be an integer and 3y needs to be an integer. Now if y was just a plain old cube root of some number, say a cube root of 2, if I raised it to the power 3, I would definitely get y cube to be an integer. But what if I multiplied it by 3? I would just get 3 into some cube root. I would never get it to be an integer. Now that is not possible, so that criteria doesn't satisfy. That cannot be a possible answer. A cube root of some number is out of question when you take both these criteria into consideration. Now the other criteria that we have taken into consideration while working with 3y to be being an integer is that y could be a fraction. Now if I took y as a fraction, it satisfies the second condition perfectly, but what about first condition? If y was supposed x by 3 and I cubed it, raised it to the power 3, I would get x cubed by 27. That 27 is never going to go away. It's always going to give rise to a decimal when divided by some number. When dividing some number, it's always going to give rise to a decimal. So y cube will not turn out to be an integer. So to satisfy both the conditions, the only possible value that exists is that y be an integer. Only in such values you would get y cube and 3y to be an integer, right? So let's now not right now. Let's not suffice with that itself. Let's try out negative numbers. You just think of any negative number, cube it. You will find that it will be a negative integer. The answer would be a negative integer. Into 3, it would still be a negative integer. Take a 0. 0 cube would still be 0. 3y would still be 0. So for any other value, it would suffice. Just any positive negative value would suffice. Just as long as it's not a fraction, it's not a decimal, it's not a cube root, it would suffice. You would get y to be y cube and 3y to be an integer only y is an integer. So since we know for sure that both these conditions will be satisfied only in case y is an integer, together, when taken together, these two statements are sufficient. So E is definitely not the answer, because E says that whatever, you either take the questions together or you don't take the questions together, I mean the options together, or you don't consider them together. The answer is never going to be sufficient. It's never going to be, both the options are never going to be sufficient individually or when taken together. So the only answer that can fit this particular question is